Hello community! As expected, we have a new large language model. This time it is called Mistral 7B and it has two specs. It outperforms Llama 2, the model 13 billion free trainable parameters on all benchmarks, and marketing claims outperforms Llama 1 on the 34 billion variant. Beautiful. Now, officially, we only have the marketing text by Mistral AI. And they tell us it's released under Apache 2, can be used without restriction for academia and industry. Beautiful. What we have an 8K sequence length, and this is it. So let's have a look at this. Now, the most interesting characteristic in the marketing material of Mistral 7B is it is open source, and it outperforms here the Llama 2 model completely. So let's have a look at this. If we look here in the very first slide that is provided in the marketing material by Mistral AI, we have here the massive multitask language understanding. And as you can see here, our first bar in orange here, Mistral indicates it outperforms all three different Llama models. Great. So in order to understand this model, we have to understand who are the people behind the model. Do they know how to calculate here the performance of Llama models? Do they know how to evaluate models? What is going on here? And they have an interesting statement in the marketing material. The future will be made of many different specialized AI models, each adapted to a specific task, compressed as much as possible, and connected to specific modalities. This is interesting since we will do this later. I will show you how we will code this, and we have a result at the performance of Mistral 7B, and you can download it to your local PC at home. So, first question is, who is the team behind Mistral 7B? Hey, here we are. A 6-month-old Paris-based startup in France, Europe. This planet, headline with a record-setting 100 million seed round. So we have here venture capital approaching, so this company needs to make money fast. Beautiful. So for me, it is just 48 hours that they released their first model. Who is management? CEO Arthur Mensch. Here we have it. Île-de-France, Paris. Great. Chief Scientist Guillaume Lample, and CTO Timothy Lacroix. Beautiful. As you can see, the first one is from Google, from DeepMind. Second, research scientist at Meta. Third, research engineer at Meta. So we have here from Meta, from Llama, here the scientific stuff. Great. Now, one very specific element is, since this is here venture money backed startup company, they have to make money, and for 6 months to come back from the US, establish itself in Europe, and release a LLM within 6 months. Okay, there was no time for a scientific archive preprint. I understand it, but hey, this is missing. We want to understand what is the content of this model, how it was trained. What about reinforcement learning from human feedback for putting in place some safeguards? All this information is currently missing because we have here from Meta some management stuff coming over, starting a spin-off, which is great. So brain drain in the reverse direction from the US to Europe, but there's a lot of information missing. So we have to go to the internet and find out ourselves. So if you go to Google Scholar, Arthur Mensch, it's a little bit strange because it shows us, hey, he's working here on psychiatric disorders and large-scale retrieval for sequence generation. So maybe Google Scholar is not the perfect source. We go to Open Review, and then we have the recent publication from Arthur Gans, Self-Conditioned Embedding Diffusion Text Generation Analysis for Compute Optimal Large Language Model Training, Flamingo. This sounds much more like a specialist in AI. But of course, really interesting here in Guillaume, And as you can see here, all his publications sorted by the year. He is an author of the original Llama paper by Meta, which is interesting. And as SiliconANGLE tells us here, he led the development of Meta's open source Llama, a large language model by Meta. So if he is the chief technology officer here for Llama, this would be an interesting point here. So, great. We have to verify this information, so we go here to the official Llama paper by Meta from February 2023. And as you can see here, here's Shilum. So, validated. Okay, so he knows how to benchmark Llama models. He knows, I suppose, everything about the details and the not published detail of Llama model. And if now in the new company they claim that they outperform Llama 2 and now just released the Llama 2 long model, this is now an interesting point. And I think, okay, credit to wherever credit goes. Those people know what they are talking about if they are from the original Llama team by Meta AI. So this means when Llama 2 was training, he left the company. So he knew exactly how Llama 2 was designed. And if 6 months later he publishes a new model outside of Meta, well, we will have maybe a preview, an unofficial preview of Llama 3 here in this, what they call Mistral 7 billion pre-trainable parameter large language model. Because if he is really the mastermind behind Llama, this will be the next step of the evolution after Llama 2. And let's assume this is Llama 3. So maybe not a complete Llama 3, but now I'm interested in understanding the technical details here of Mistral 7B. And it really hurts to have no research paper. Okay, here we go. What do we get? We get two models. We get a pre-trained Mistral 7B, 7 billion pre-trainable parameter model, and we get a fine-tuned Mistral 7B model for some chatty LLM, and it is of course called Mistral 7B Instruct. And according to the marketing material by Mistral AI, it is fine-tuned on instruction dataset publicly available on Hugging Face. So there we have the beginning, the startup of a new company, and they say the next models will follow in short term. So this is what they start with. Interesting. Now, let's have a look here at the fine-tuned Instruct Mistral 7B model. And as you can see, performance data are nice. Really outperforms Llama 2, the 13 billion chat version from Llama 2. Now, if this is a preview of Llama 3, it should outperform Llama 2. So, interesting. So if really a 7 billion pre-trainable parameter model is able to outperform the next class, the 13 billion parameter class, this is what I would expect from Llama 3 to make a jump of a complete generation. Infrastructure. What is their computer infrastructure? As they mentioned, they had access, or they had the help of CoreWeave. CoreWeave, GPU Cloud, professional. Okay, I would also go with CoreWeave. Check. Then they thank here the European high-performance computing team, in particular the operators of Leonardo. This is a European supercomputer co-founded by the European Union. It is a so-called European joint undertaking. Forget about it. This is some administrative construct. But as you can see here, this construct is also now here planning to establish here 6 new quantum computers in Europe, France, Germany, Italy, Spain, and so on. So they are building here now on this computer infrastructure. So if they have access to a supercomputer here in Europe, okay, they can do the basic fine-tuning. So here we are now in a free COLAB notebook. I have here my Mistral 7B. From my parameters, it is easy. The temperature is 0.5. The parameterization top K is 55. top P is 90%, and the repetition penalty is set to 1.2. So let's execute this now. And as you can see, I've chosen a version that your GPU VRAM stays below 8 GB. So if you have an 8 GB GPU, you will see you should be fine with about 6.2 GB. And here we have now the result. This is the answer now by Mistral 7B when I ask him, hey, explain quantum entanglement in mathematical terms. Of course, you can modify the parameter and you will get different, more complex, less complex explanation here of Mistral 7B. As you have seen now, we go here to the official documentation by Mistral. Just tell you, 48 hours ago it was published. If we go to cloud deployment, where can you run Mistral 7B? AWS, Azure, Google Cloud Platform. So let's have a look how to implement this. AWS, instruction will follow shortly, but they recommend at least 24 GB of GPU RAM to properly serve the 7B model. So nothing on AWS here. If you see this video, please go there and maybe you will have now the AWS code instruction. Google Cloud, instruction will follow shortly. Yes, this is a really early on video. Azure, instruction will follow shortly. So we have no idea how to use this in the cloud if you are not experienced. So let's do here the local deployment of a Mistral 7B model on your PC, or maybe we go to a free COLAB notebook. So let's do this. What is from the technology the most important fact? What are the elements that could indicate to a LLama 3 model? What we have that is outstanding. Let's start with the last one, a byte-pair encoding tokenizer. If you are familiar with this, check. If not, this is the video for you. I have here a video here about BPE tokenizer from scratch. It's a year old, so nothing special. And then I show you here, if we build here a sentence bird system, a domain knowledge system here with the BPE tokenizer, here you can see the BPE tokenizer in action in a complete code sequence. Great. Second, sliding window attention. So here an attention window that uses here a sliding window. You might say, if you are a subscriber of this channel, hey, we know this. In this video about the mathematical AI, the donut and the nougat, here you showed exactly how the swing transformer, the shifting window transformer work, what are the benefits, why it outperforms other things. Then you had a look here at Microsoft's new Cosmos 2.5. where they did not mention a swing transformer and they did not perform as good as Nougat. And of course, I focused here on the topic also in my long LoRa video where I showed you if you combine it with flash attention for the GPU process optimization. Also there we have here the sliding window. So this is something established. This is already 2 weeks old. So what we are left with is grouped query attention. What beautiful is a grouped query attention? Now, at first, we start with the basics. Basics is the multi-head self-attention of the transformers. How to explain this? If you are unaware of Q, K, and V in the self-attention of transformers, this is the video for you. 1 year old, but very informative. And have a look so you understand the basics. Multi-head is here the most important word. Of course, there was an official Google research paper, and you remember the CEO of Mistral is coming from DeepMind Google Research. Beautiful. So we have here a transfer from the knowledge of Google and a transfer from the knowledge of Meta combined now in Mistral. So we have here May 22nd, 2023, we have here multi-query transformer models for multi-head checkpoints. And you might say, hey, fantastic. So if you want to have a deep dive into this, this is the research paper for you. If we just have a look at this, this is the sentence for you. Google says we proposed grouped query attention, an interpolation between the multi-head attention and the multi-query attention, where the multi-query attention with a single key and value heads per subgroup of query heads. So we understand this thing is living here as an interpolation between multi-head and multi-query attention mechanisms, and it is an approximation to be faster, but try to achieve the quality of the good old multi-head self-attention mechanism in transformers. If you say, okay, one sentence more, beautiful. Grouped query attention, generalization of the multi-query attention. The group query attention aims to achieve the quality close to the good old multi-head attention, while maintaining here the speed advantage of a multi-query attention. Great. So what we need to implement this well, for May 2023, this group query attention, now two things. We need to uptrain here our multi-head attention models to the multi-query attention models. And I will show you how we do this, rather easy. And we have here this new group query attention, which simply interpolates between those two models. So we might say, hey, sounds simple. It is simple. So at first we have here this two-step uptraining process for converting a multi-head attention model to a multi-query attention model. The key and the value projection matrices from all heads are pooled into a single head, followed by additional pre-training. As easy as this, it is an approximation, so you make a simplification to be faster. That's it. And then you have your grouped query attention, and this divides the query heads into groups. You know this from Visual Transformer or anything else. If you have something, group it together and assume a single key and value head for this group. Therefore, you are faster. You only have to calculate one single key and value head, and you hope within your group boundaries to have a very good value for this tensor structure. Now, the number of groups can vary, so the resolution can vary, allowing for a trade-off between the parameter of quality and speed. So you choose the number of groups if you want more quality or more speed. Beautiful. Third view, this group query attention can be seen as a generalization in the parameter space of the attention mechanisms. It allows for a continuous trade-off between the extremes of the multi-head attention and the multi-query attention. As easy as this. Now, for my youngest viewer, Ben, this is for you. A very simple example so that you understand here on an example what is a group query attention. And I use here GPT-4. I found this helpful for GPT-4. Imagine you have a neural network trained to recognize digit, handwritten digit from 0 to 9. Now, the simplest network we know has 3 layers: input, output, and in the middle we have the hidden layer. Now, the aim or the goal is here, you want now to extend this network, to upskill, to uptrain these networks, to this neural network, to recognize now also characters, alphabet letters, A to Z, in addition to your numerical digits. So instead of training now a complete new network from scratch, you can use this uptrain procedure to use the existing one. And you know how we do this. Initial state, 3 layers, input, if it's a visual, 28 times 28 pixel, the historical value. Then you have 128 hidden nodes, and you have the output nodes. And since you have digits from 0 to 9, you have exactly 10 output nodes. You know this. How we do the uptraining now to include characters? You add 26 new nodes to the output layer to accommodate now the additional letters from A to Z. So to your 10 nodes for the digits, you add now output nodes, 26 new output nodes for A to Z. Now the complete output layer of this uptraining network has 36 nodes. And then you notice fine-tuning. You continue to fine-tune this extended uptrained network on a new dataset. And now you remember you have to include both the old one and the new dataset. So you include the digits that the network has already been trained on, but we want to fight the catastrophic forgetting. So we train here on the digits and the alphabet, A to Z. This is it. Quickly learns to recognize now the alphabet letter 2. This is uptraining. And this is, if you want here, the main point here in the group query attention to uptrain here this model. So now you might say, okay, what is this grouped term? Now, as you can see, here's the uptraining, and now we go to the grouped query attention. If your uptrained network is doing well, but it's a bit slow because it's currently examining each and every pixel in the image multiple times. This is exactly the multi-head attention mechanism, looking at each word multiple times if you think about natural language processing. So we want to speed up now the computation within this network without losing the accuracy of this network. So what we do, we find new group structures. So you decide to divide the 784 input nodes. Remember, we have a 28 by 28 pixel raster. And this inputs node, we have now 4 groups. So each of the 4 groups has about 196 nodes each. So each group will look now at a different quadrant of our photo, of our image. And then shared processing. Within each single group, the nodes share some common processing step. This is akin to sharing a single key and value head in our grouped query attention. This is it. It is a simplification. So within the group, you do not calculate each and every tensor structure, but you calculate and share here the key and value heads in your group. This is it. So in here, the group query attention, the query heads are divided into groups, and within each group, it shares a single key value head. This allows here for this trade-off we're looking for to get almost the same quality, almost the same accuracy as when each query head had its own key and value head, like in our multi-head attention, like in the good old multi-head attention, but with less computational cost, since we are using here some common or some single key value head within our group boundary conditions. So we are faster, we have less computational cost, and this is similar to the multi-query attention. So you can see in the interplay, in the approximation here, that you want here the quality of the multi-head attention, but you want the speed and the cheap performance gains by multi-query attention. This is exactly what you have to balance. Ben, this was for you. Back to the main group. Now, officially, the team of Mistral said, hey, to run this here in floating point 16, you need the absolute minimum GPU RAM requirement just for inference 16. So you know it is 24 gigabytes. And also the same for the Instruct model. So for a 7B model, 16 to 24 gigabyte VRAM is quite hefty. So if you go Hugging Face Mistral, as you can see, in the last 48 hours, I had 1,500 downloads. Yes, you find everything over there. They explain what they can, because also they have no research paper, since this is a company, a startup that has to make money. Okay, and as I told you at the very beginning, they tell us that they want to compress their model as much as possible. So let's do this. Let's take this step that they announced for their next models, and let's do it right now. How we do this? Now I have to be consistent with my videos, so this is the video to watch. GPT quantization and GGUF quantization methodologies on C++ for Llama for auto GPT quantization on your local PC. To understand what's going on now in the next 2 minutes, please have a look at this video. Otherwise, it might be hard to follow. Great. In the video I tell you on Hugging Face, there's my preferred source of quantization. It's called the bloke. And here Tom shows us exactly the Mistral 7B Instruct GGUF model. Great. You remember, in general, we have a lot of possible ways to apply and to make here Mistral 7B executable on a cloud machine or on your local PC. Now, you can run here the original unquantized floating point 16 model in PyTorch. Great. Or what we will do, we will go to a 5, 6, 8-bit quantization based on the GGUF models for pure CPU or CPU and GPU inference, where we can decide how much we want to offload to GPU layers. This is the code I'm going to show you. Of course, you remember here, GPTQ is the other quantization version. You can do this for the GPU inference or some other thing, but we will focus here on the 5, 6, and 8-bit GGUF models for either run it locally only on your CPU, and you need a lot of time, or you offload here to your GPU. What models are available? This is a screenshot for me. As you see, updated 8 hours ago. We have our Mistral 7B Instruct GPTQ. We're not going to use this. We have the non-instruct here. Then we have the instruct here, the GGUF. We will use this model in my code. And we have the non-instruct GGUF. So this model and this model, I will show you how to code. You can go with other quantization as you like. No problem at all. So if we follow now here, these are the models that the bloke published on Hugging Face. So here you have the pre-trained model for Mistral 7B, and here you have the fine-tuned model on Hugging Face datasets, and it's called Instruct for the instruction fine-tuning. So I will show you very simply the Instruct version, and here we will go for a specific model where we see the max RAM requirement. Please note, this assumes that you have no GPU offloading. So this is your system RAM. And if you have a GPU and you say, yes, I want to offload some of the calculation to my GPU, this RAM requirement reduces. But of course, you need to have the corresponding compute power, the VRAM, on your GPU. And what we will do, we will have a look here at the Q4 and at the Q5, and maybe also show you the Q8. Beautiful. You see here from the bloke, wherever he says, hey, medium, balanced, recommended, here, large, low quality loss, recommended. You know, this is an interesting model. So the size of this particular quantization, the size is 5 GB, and you need RAM at least, well, let's say 8 GB. And if you offload to your GPU, less. Beautiful. So if you want to try out Mistral 7B and you have only an 8 GB VRAM graphic card, this is the simplest installation I could find for you. So first is simple. A pip install a CTransformer for CUDA. Beautiful. If you have a CPU only, you just get rid here of the CUDA, or if you want here to go with here the GPTQ quantization, you have here exactly this command. So we go here with CTransformer. This is a very efficient implementation. Then of course we have here from CTransformer, we import, as you know it, our auto model for causal language model. Great. Then I just have here a very simple text function. Beautiful. And then here we go. This is it. One line of code. So you have here your LLM. This is your auto model for causal language model from pre-trained. And now, as I showed you, we go to the blog, the Mistral 7B Instruct, the fine-tuned Mistral 7B model. Remember, the whole thing is just the version 0.1, so we are the leading and bleeding edge of LLMs. Then we go here for a very specific model file. And I have chosen here the Quantization Q4KM as a GGUF. Go whatever you like. The model type is simply Mistral. And since I have here a GPU, I go with GPU layer offloading, as I showed you in my video, with 50. So this can be done rather fast. Let's do this here that you can see it here in real time. That's simple, the file download. And you see we have here 4.37 gigabyte of file transfer, and then we have our LLM. Beautiful. If you want to go with any different version here of the quantization, you remember, here we are. This is it. These are the versions you have available, and you have here the max RAM requirement. Remember this. So you can go here with a Q2, with a Q3, with a Q4, and you have here from the blog here the use case. And whenever you see here medium balanced recommended, this is something he would recommend. So this is exactly what we loaded here, a Q4KM. You see here, you have, if you do not offload to the GPU, you have here about 7 gigabytes of RAM. Beautiful. This is it. You can go here with recommended. You can go with a large one. I will show you a large one with a very low quality loss. This is only also recommended. And as you can see, we only also have a Q8, very large, extremely low quality loss, but for some reason it says not recommended, so we need about 10.2 gigabyte of RAM. We will have a look at this also. So you choose the file version for your specific computer. Beautiful. So this is it. Or as I showed you here, let's do this one. I go here with a Q5. Q5 is here the medium recommended version. So let's do this. You can see it in real time. It's real fast. Now, if you load a second model, your GPU RAM goes up a little bit, of course. So maybe you start here with one model, but we have your session crashed. Diagnosing. Unknown reason. Now I have a feeling I know exactly what is the reason. So no problem at all. Runtime, disconnect, delete, beautiful. Change runtime, we have here a T4 GPU, beautiful, save. So we have to do this again. Import here our CTransformer, say thank you. And then we go automatically here with this model. Should take just about half a minute to a minute, and I will be back with you when this model loads. As you can see, 20 seconds later, we are here with a 5 gigabyte model. Beautiful, this is our download. It is a weekend, so it is a rather low internet connectivity here on my end, but never mind. And as you can see here on the right hand side, you have the system RAM, you have your GPU VRAM, and you have your disk space available. So we are still loading here the model. Yes, beautiful, done. And as I showed you, this is it. Now you just say, hey, Mistral, this max new tokens, I set to 2K length, the temperature, yes, increase it, decrease it. Yeah, let's go crazy. Let's be really creative. Top K. Top, yeah, let's go down. Let's be a little bit out of the ordinary. Let's be imaginative. 1.1, and let's run this one. You see, GPU is well into the limit. And we are waiting here for the execution. I'll let it run here in real time so you can see GPU RAM requirement. And this is it. So on my explain quantum entanglement in mathematical terms, Phenomenon, two particles become correlated in such a way that the state of each particle cannot be described independently. Yes, yes, yes. Spooky action in the past. At a distance, beautiful. And as you see, I have here already different temperatures readout here. So this is the text generated with a temperature from 0.5. This is the text generated by 0.7. Beautiful. So you see, there are a lot of different options for you. Now, if you want to go with something else, let's go with something else. So now I say, hey, what do you know about the Mistral 7B model? So let's see what the model knows about itself. Okay, maybe the temperature from 0.2 is not really perfect. So, very short information, yeah. It was announced in October 2021. This is definitely wrong. So, okay, temperature is about 9. This goes up to, just have to adapt here my parameters. Let's see if we can optimize this. I'm not familiar with the Mistral 7B model, but I can tell you it's like a type of a machine learning model. It's likely a type of transformer-based model. Okay, so no information about Mistral 7B. Great. Yeah, let's go with something controversial. I say, hey, explain the pros and cons about electric cars like Tesla. Temperature is 0.9, top K is 55, top P is 0.93. Penalty is still there, so let's see what we get back. And here, as you can see, GPU RAM, system RAM, everything is beautiful. We have a beautiful quantization of Mistral 7B. Of course, it is a simplification, since it is a quantization, but you can see this is a 7B model. So here we have the pros. And here we have the cons. So let's go. Pro, environmentally friendly, low maintenance cost, okay, reduced fuel cost, okay, quiet and smooth driving experience, okay, tax credits, hey, tax credit, that's great. Cons now we have the limited range, yeah, high purchase cost, okay, what we have here? Longer charging time. I hope this is gonna change soon. Limited charging infrastructure, especially true in Europe. Here the US is really very, very well advanced. And a limited model availability. Yes, there are much more gasoline-powered cars available to a potential buyer than in Europe we have electric cars. So I think here for a 7B model, the answer is quite impressive. So if you want to try it out yourself, as you can see, you have exactly one line of code. You go here from Hugging Face, the block, Mistral 7B Instruct. You choose the quantization level. You say, hey, it's the type is Mistral. You choose your GPU offloading of the layers. I've chosen 100, go with 50, whatever you like. And then simply experience here with the temperature, with the different parameters that you have for the sampling. You can go maybe even with beam structure, repetition penalty. Go and explain it yourself. It is so easy, and as you can see, download it to your local PC, and with 6.2 VRAM, this is no problem at all if you only have an 8GB GPU. So, this is from the coding side. Couldn't be easier. Great. So now you know how to code your own Mistral 7B model. A lot of information about 7B is missing since there's no research paper. Okay, we have to accept this, but we know how to make this model even better. We know the next step in the evolution of this model. Now we know that it is rather easy to imply here the long LoRa for a Mistral 7B, I don't know, 64K or Mistral 7B 100K context length. This is with long LoRa now available. The publication of long LoRa happened when, at the time of Mistral 7B training, So they could not integrate it in the training phase. But now that we have this model, we can do now the fine tuning that is required here for the long LoRa extension to a Mistral 7B 100,000 token length LLM. First step is here clear. Second step, I will show you if this is really something going in the direction of a Llama 3 model. And as I showed you already today, Mistral 7B outperforms here the Llama 2 7B and the 13B model completely, so they jump a generation in the performance. We want to see here the chain of validation. Is it already applicable here on a 7B model? Because you know that the normal models where we apply here a self-validation of our large language model, this is happening at models with 70 billion free trainable parameters. And if you're interested, this will be the topic of upcoming videos. So for today, I say thank you. This was 48 hours after the release of this model here, where we have no research archive preprint. As summary, I show you what is new, how to code this model, and how you can make this model even better, because you understand the internal working of the model and you understand the technological possibilities we have today to make this model even better. See you in my next video.